Hello students, welcome to the channel Concepts for Medical Students. Today we'll be covering part 2 of the topic body fluid compartments. The first thing that we are going to learn in this lecture is Darrow-Yannet diagram. So Darrow-Yannet diagram is a graphical representation of body fluid compartments. Here we represent volume on the x-axis and we represent osmolarity or the solute concentration on y-axis. So now assuming for the sake of simplicity that we have a person who weighs 100 kgs, we know that total body water is 50 to 60% of the weight of the body. So assuming 60% of the body weight to be body water, we get 60 liters of total body water. And we know that 2/3 of this water is ICF and 1/3 is ECF. So we represent 40 liters of ICF and 20 liters of ECF. So this point here will be 40 liters and this point here would be 20 liters starting. So we have a person of 100 kgs weight who has 40 liters of ICF and 20 liters of ECF and osmolarity equal to the normal body osmolarity. And one thing that we have to remember that is actually very obvious is that the osmolarity of ECF and ICF is same and it should always remain same, because whenever there is a change in osmolarity of ECF, it will be reflected in the changes in the ICF. Another thing that we need to remember is that when a body gains fluid, it the, the changes are primarily reflected in ECF. Similarly, if a body loses fluid, the changes are primarily reflected in ECF. And later on, there are secondary changes in the ICF. Now we will discuss what happens to the ECF and ICF when there is addition or reduction of fluid of varying tonicities from ECF. The first example will be that of losing isotonic fluid. So let's assume a person is losing isotonic fluid. This is how we will represent it. So assuming a person has lost 2 liters of isotonic fluid, there will be reduction of 2 liters from the ECF compartment. But as the fluid lost is isotonic, there will be no change in the osmolarity of the ECF. As such, there will be no change in the osmolarity or volume of the ICF. This such a scenario is encountered in cases of hemorrhage or when a person is forming isotonic urine or early consequences of diarrhea or vomiting. The second scenario is loss of hypotonic fluid. So again, this compartment represents this compartment represents ICF, this compartment represents ECF, and as we have learnt already, any loss of the fluid will primarily be reflected in ECF. So loss of hypotonic fluid actually means loss of water more than loss of solutes. So as a consequence, this is how we reflect water is lost. Water is lost. So as a result of loss of hypotonic fluid, what we say is that there is a net loss of water. The osmolarity of ECF will increase. So once the osmolarity of the ECF will increase, what's going to happen what's going to happen is that there will be shift of fluid from ICF to ECF. So ICF will also lose some fluid to maintain the osmolarity, to maintain the balance between the osmolarity of the ECF and ICF. We encounter such situations in sweating, with inadequate water intake. Number two is a person suffering from diabetes insipidus, when a person forms a lot of hypotonic urine. So in the both conditions, what we see is that the osmolarity of the ECF and ICF is raised, and there is loss of fluid from ECF and secondarily from the ICF also. The third scenario is that of gain of solute. Net gain of solute means gain of hypertonic fluid. So, as we know, once there is a gain of fluid, this will be represented like this, but it's a gain of hypertonic fluid. So the overall osmolarity of ECF will increase. So this is how we represent the overall. But now that the osmolarity of ECF is increased, what we expect is that fluid from ICF will cross the cell membrane and enter into the ICF, because we know whenever there is a semi-permeable membrane or selective permeable membrane between two fluids of varying osmolarity, fluid moves from area of lower solute concentration to area of higher solute concentration. So here what happens is that ECF volume has increased, ICF volume has decreased, and osmolarity has increased. So what are the scenarios or clinical situations where we encounter this? We encounter such a situation because of infusion of hypertonic saline, high salt intake, mannitol, when we inject mannitol, and when we give colloids. In all these situations, we add hypertonic fluid to the ECF, so the volume of ECF is increased, the osmolarity of the ECF is increased, and as a result, fluid shifts from ICF into the ECF. The next scenario is that of net gain of water. That is adding hypotonic fluid to ECF, or it means ingesting large amounts of water, infusing hypotonic fluid or saline or dextrose in water to the person. So what happens is that, as we know, point is that ECF is gaining water, but at the same time we know that it is hypotonic fluid. So the fluid, the volume will definitely increase, but as it is hypotonic, the osmolarity will also decrease. Once the osmolarity of the ECF will decrease, that means the osmolarity of ECF at this point is less than the osmolarity of ICF. As a result, fluid will move from ECF into ICF. So there will be increase in ECF as well as ICF. So net result is ECF is increased, ICF is also increased, but osmolarity is decreased. As I've already said, such a situation arises when a person takes a large amount of water, or for some reason the person is given hypotonic fluid, like in the form of hypotonic saline or dextrose in water, etc. The next scenario is actually very simple. It is gain of isotonic fluid. This simply means this is ICF again, this is ECF again, and as I have said, there is gain of fluid and it is isotonic. That means there will be no change in the osmolarity of the ECF. Simply there is increase in the volume of ECF and there will be no shifts because osmolarity has not changed. So this happens when a person is infused with normal saline, what we call isotonic saline, or what we call normal saline, or a person drinks a lot of isotonic fluids. So net result here is ECF increased, ICF no change, osmolarity no change. The last scenario that we are going to discuss is loss of hypertonic fluid. So what happens is loss of solute more than loss of water. So first thing, there is loss of fluid that will be reflected in decrease in the ECF. At the same time, the loss of fluid is hypertonic. That means more of solute is lost. As a result, the osmolarity of the ECF will be reduced. So once the osmolarity of the ECF is reduced, we know that water will shift from ECF compartment to ICF compartment, meaning there will be swelling of the cells. So net result will be ECF volume, of course, is decreased, ICF is increased, and osmolarity will decrease. I think that is all for today, and we'll meet again with the microcirculation. If you have any questions regarding this topic, you can ask the same in comments. Thank you very much.